Well, thank you so much. Today we're going to talk about challenging your assumptions. This deck it's only 10 slides, but it's going to stretch your mind, right? Each one of these slides is going to be an introduction of a thought process, and we're going to stitch it all together in the end. So good morning. This isn't your typical tech presentation. We're about to explore how the convergence of food systems, energy systems, and advanced technology can fundamentally reimagine economic development across America. Now, I don't say business development, right? Because that's like, the capital side of things. I talk about economic development because it blends people, the humans that need jobs, right, with the economy that we can create. What you'll see today isn't just about innovation. It's a replicable blueprint that any region can adapt to. We're connecting what I call 1,000 points of light here between technologies, the market opportunities that exist, and how we can integrate these to create something truly unprecedented. This is Massachusetts, right? We're supposed to create truly unprecedented things that lead our nation. By the end, you'll understand how this technology is not a moonshot 10 years away, right? This is usually when I start these people are like, oh, wow, it sounds like moonshot. It's not moonshot 10 years away. It's ready now. Regulatory pathways exist. And Massachusetts can lead the nation. We're going to talk about those assumptions being challenged. We're going to reveal some of those unexpected connections. We're going to talk about how to use this to transform the nation. But let me establish why I'm qualified to present this vision. My journey started as a Navy power plant operator at about 18 and a half years old. I dropped out of high school at 16 because I needed to feed myself. And by 18, as a high school dropout, I was able to get to the Navy, and from there, I got here. Okay. Pioneering is something that kind of comes genetically with me, right? Curiosity, understanding. Anyone ever go to the Hanover Mall when they were a teenager and you see that ball at Spencer's, that plasma ball, and you walk by and you put your finger on it and you're like, what is it doing? I could not live a life that didn't understand how everything worked. And so today I'm going to share some of that with you. I helped pioneer telemedicine technology at Partners Healthcare. That's, of course, after having pioneered it at the VA here, Vision One. I worked at the VA after I left the Navy. I literally helped invent internet-based video conferencing. Here's how. I had started telemedicine for Partners Healthcare. We had done international telemedicine calls over the internet, right, forever, or at least for a year and a half. Silicon Valley found out about it, and they thought, the internet? What? They didn't know how to spell it, right? These are senior executives, 15 or 20 years older than me, and they brought me in, and they said, Tim, we think this internet thing you were doing with telemedicine is pretty cool. Do you think we could use it for telecommunications and things like that? And I said, yeah, but there are 5 obstacles. I patented the #1 obstacle to get from one enterprise to another enterprise over the internet. And that set $1 billion worth of acquisitions into play and had that little tiny company called Polycom standing up on the shoulders of Cisco and Microsoft in my career. Okay, so from a little idea, right, to market dominance. Those Zoom calls that you all love so much, you're welcome for those. But here's what matters today. Massachusetts Manufacturer of the Year, right. You spend 20 years in high tech, you do your Silicon Valley thing, and then all of a sudden you're 50 years old, and, well, we all know what that's like, right? You're either going to be in a leadership position on your own, you're going to maybe fight the corporate deal or retire, right? And so I thought at 49 years old, I'm not going to be retiring at 49 years old. I want to do something new, and so this is how we got to Wellness Croft. I've proven I can execute complex visions through my work with Farm to Institution here in New England. We've been tracking how farms get their products into institutions now for 5 years. I've been working with the Western Mass Food Processing Center for a number of years now. I've been doing a lot of research and development with an AI team I'll introduce you to at the last part here. Really trying to build models that haven't existed before. Models looking at different technologies, different business models, and different plans, and trying to squish them together in ways that no one ever thought about before. Artificial intelligence is very useful for this kind of dynamic thinking. This, I thought of something, oh, well, he thought of something. Well, why don't we give it to AI and let's see what AI thinks of something, right? And we've learned through this ways to think, and I'm going to share them with you today. This isn't a theory. It's a proven capability applied to transformative opportunities, and I hope by the end here you're going to see how this all plays out. My life, as I said recently, started in the Navy, then it went to telemedicine. Telemedicine was an interesting stop. gentleman by the name of Dr. Joseph Kvedar. He's still very famous in telemedicine. He's basically the guy who took telephone telemedicine and found me, right, and created video telemedicine. He was the American Telemedicine Association president for many years. But I got there because I'd first been working on power plants in the Navy. I became you call a second-class petty officer. I was also an enlisted surface warfare specialist. And back in 1988, August, I was in the Persian Gulf during the Iran-Iraq War. The one-day war between the United States of America and Iran. We won. Strange times for me. But during my time in the Navy, I had been involved in the Black Sea with the Cold War in Russia. I had spent 2 tours during drug and addiction in the Caribbean, where we did not kill a single person during any of our drug interdiction work. And then I spent a year in the Persian Gulf area during a time of war. I have an Armed Forces Expeditionary Medal for that time served. I was also an enlisted surface warfare specialist. You don't get to be one of those unless you're going to war. And we like to thank President John F. Kennedy for that, because he created the enlisted surface warfare specialist designation after the Bay of Pigs. So that's my background. Starts with the Navy, went into work for the VA. After I left, I wanted to still take care of the veterans. I started telemedicine there at the VA in Brockton. From there, I was recruited out by a manufacturer who was working with a big budget at Partners Healthcare, Mass General, Brigham and Women's. I had offices in both locations. From that point, the world was turning, right? We're talking about 1998, 1999, 2000 times are coming. Internet's really starting to become popular. We'd passed 9,600 baud modems. We're in a 56K, right? I had 384 kilobits through 3 ISDN lines to my house in Norwood. 384 kilobits up high as my house. Woo! We were roaring. But it brought me to an opportunity where I sat down for the first time with a bunch of people who had a whole bunch of money. These are Silicon Valley executives. They could find money like nobody's business. And they wanted ideas. And I simply wanted to solve a challenge I'd been trying to solve for many, many years. Why can't we run video across one transport instead of the 6 networks I, as a systems engineer, have been having to manage forever? That ability to consolidate all these protocols and all these applications down to one single protocol is how I got into Silicon Valley, and that's how the Zoom pieces came about. This is, I try to put the punchline at the front of the, as the title of the slides. This one here really is about how systems thinking. In the Navy, the first thing they teach you as an engineer, they call us snipes. It's not the most popular kind of thing, but a snipe is a guy who's down in the hole. And what they teach you about systems engineering is this: how to walk through the whole power plant one hand at a time, following every single pipe, every single wire, understanding where every single thing goes. If you don't understand how it all works, how are you going to ever figure it out in the instant where it's very stressful and you have to solve that right now, right? So that systems thinking started there. I then moved on from naval power plants, automation, basically the early robots, boat davits, elevators, things like this, electrical automation. And I moved my way into the electrical trade here in Massachusetts. I'm a former licensed systems technician, a former licensed systems contractor, architect, 10 stories of buildings I could design, fire security access control. That was my background. Very complex systems, life safety systems, right? First combat systems, right? Now life safety systems. Lives are on the line for my career, my first 15 years. I make a mistake, people die, sometimes lots of them, right? No mistakes can be made. That requires a rigid level. I mean, there's a physician in the audience we're just talking about, right? People die, right? We have to have protocols. So learning complex systems thinking is something that I kind of did naturally. One year, I was at a trade event, and a gentleman from MIT, a PhD, showed up. We were talking. He'd heard me speak. I just pitched the new architecture for Polycom, the architecture that currently is owned by HP. Still the same architecture. Hasn't changed in 10 years, right? Because it was right then, it's still right now. The point is, he said to me, Tim, how do you do it, right? You're a young guy. I've got a bunch of other guys that compete with you, but you're kicking their butts in board meetings every week. What are you doing? What's different? And I said to him, I just kind of think of things as a system in my mind. And I didn't know about systems dynamics at that time. So any folks who are from MIT or know about it, this is how you think, right? Systems dynamics. It unveils the secrets of what's happening behind. It gives us ideas, ways to move forward. And so systems thinking has allowed me to take things and break them apart. This pretty picture here right now is kind of what my mind thinks about when I think about the Plymouth Food and Energy Hub, right? Moving to a point where technology kind of integrates across different domains. We're going to get to a slide in a few minutes here talking about these different pillars. But here's where we shift from talking about me and what is possible. Traditional thinking puts us food in one box, energy in another, and technology in a third. But what happens when we eliminate the boxes? It's not theoretical. We're building this in Plymouth right now. We've been doing it for 5 years. But it's just a proof of concept right now. At this point, we're scaling at revenue, but we know we need to get a lot bigger. We need better energy systems to get bigger. Our integrated approach can be adapted to any region. I'm building a prototype of something I think is really cool. But the point of it is that it's not just cool to me. It could be cool to every region in our country. And you're going to see as we go. The genius isn't that it's any single technology. It's really about how we're going to integrate these things together in a cogent plan that I think traditional approaches cannot achieve. I've been trying to raise this company up for the last 6 years. When you talk to people about food, they have a very antiquated view of food. When you talk about energy, I can't tell you the first few conversations I had about micro modular nuclear reactors with people. I mean, like eyebrows up the top of their head. And then when I said, no, private, they went, what do you mean private nuclear, right? And they didn't understand, well, that's where it's going, right? It's going that way. By the way, that was Senator Dylan Fernandez, who told me last week, by the way, that they will be passing the 503 chapter, which removes the statewide ballot initiative requirement for nuclear in Massachusetts. We're getting closer and closer to what I call Massachusetts nuclear renaissance, and it's happening daily. So system thinking at the finest is what we're going to cover here. We're going to talk about a concept of AI triumvirate. And AI triumvirate, so if you're going to build something that's that complicated, right? I mean, if you look at it, we got nuclear power plants here, we got controlled environment agriculture that's happening right now. We've got food waste from controlled environment agriculture. What does that do? Well, food waste is a component to a hydrogen production system. How do you create hydrogen? Well, you need latent heat. Where do you get latent heat? Well, new micro modular reactors, they don't have cooling. They have heat, latent heat. You can use the heat to create electricity, steam, to create hydrogen with food waste. Again, there's synergies across. When you start to dissect these pieces, you look at all the components, you say, well, that could work over there, and that could work over there. And so when you look at it from this perspective, all of a sudden, the idea of nuclear, right, powering it underneath becomes the key, right? You have to start with something at the foundation. For me, I started with food. But what I found out is I can't grow food, I can't scale food until I solve that energy piece. Right? And everyone has the same problem. We have broken food chains throughout the United States. We have a broken electrical grid throughout the United States. Imagine if someone was so bold as to suggest he could solve all of those problems all at once across the entire nation. We can. We can. So it's like building a cake. This is some more art for my AI team. Taking energy systems, controlled environment agriculture, and putting the food processing on top. Food processing is an interesting market. CPG, consumer packaged goods. There's a multiplier if you're a good CPG company. 14.5 times your earnings before interest and taxes, EBIT. If you're a betting person and you want to get into a business, you want one that 14x's your investment. The problem is it's volatile. It's a volatile market. It's maybe they'll order, maybe they won't order. So how do you put some sustainability in the CPG market? You go to contracts, large-scale contracts for food. Do you realize in Massachusetts that there's no large-scale contracts for food grown in Massachusetts to go into institutions in Massachusetts? Imagine this. New England doesn't even feed itself. 85% of the food in New England comes from outside of New England. And what I'm going to reveal to you in a moment is, where's it coming from? And is it going to still keep coming from there? I don't think so. And we're all going to understand why in just a moment. I talked a little bit about the nuclear power component, and that really is the piece that makes it all happen. A nuclear reactor will cost me about $111 million. $50 million of that is fuel, and that's for the whole life cycle. It will generate about $29 million a year in revenue. That's a sub 5-year ROI. This is a great business plan. The internal rate of return on these investments are in the double digits. So in the finance world, I'm not a finance guy, but I've come to learn you better know how to speak finance if you're trying to raise some money. But the internal rate of returns are double the efficiency when you think in this kind of model. So again, nothing works in isolation. The energy creates latent heat to power the manufacturing and agriculture. Agriculture we're talking about here is controlled environment agriculture. These are glass houses that are 365 running. They have a controlled environment that's comfortable for the humans. There's automation that augments the humans. The AI triumvirate piece that we talk about has to do with not humans being replaced by robots, but building a paradigm by which, and we do this every day. In fact, we have a very small crew right now. And the reason we have a small crew right now is because every time I have to hire somebody new, we find a piece of automation that makes the crew even more efficient. Or we find a piece of software or a process that we can use through AI that creates yet another layer of efficiency. We're developing workstations whereby there's a human, there's an artificially intelligent agent, and then this is important, an artificially intelligent robot. Robots before were not artificially intelligent. They are becoming so. And now that you have the substrate of AI, control, and AI robots, and a human, you put them into a combined workflow where one helps the other. You get safer, you get more efficient, right? You have more reproducibility. It all happens in a way that improves the, my employee got her first robot. the look on her face was like, oh my God, what am I gonna do with that? And by the end of the day, the smile was like here, because she was concerned about her productivity. And when her productivity 10x that day, the smile, the joy, the happiness to come to work, knowing she's going to conquer her problems today because she's got automation and she's got a plan that she put into play. AI triumvirate is the new way, because when I talked about AI earlier on in some of my presentations, people were like, oh, AI, it's going to take our jobs, right? You know, oh, nuclear, it's going to blow up the world. Come on, people. You got to look at them differently, because when you put them back together, they make something new. Now, we talk about those three silos that used to be apart from each other. And my curiosity and the planning that we've done at Wellness Croft has led me across these silos to find the pieces that we can help use to put them all together. So I talked about the triumvirate. Food workers generally make between $15 to $21 an hour. That's not the kind of career path where someone's going to want to come to work every day or spend their time with your company for a number of years. I don't believe in low-wage work, personally. I've always been a skilled laborer, right? I don't believe in low-wage work. I believe if you have a low-wage worker, that's the person who's their helper, who's moving their way up into a skilled job where they get higher pay and they get better compensation. I'm a blue-collar guy originally. I believe in workers, and I believe in having jobs for people. And we know. When you have a person with a robot using AI, they're more sophisticated, and we should pay them more. And they're more productive, so we can pay them more. What about agriculture? What if you could be way more efficient? This 98% less water is going to come into play in the next few slides. Energy systems. So 18% more energy efficiency per kilogram grown. That's a double-digit efficiency improvement in growing, right? That's huge. It's year-round. That's huge. Same investment, right? I've got friends in Canada. They giant strawberry farms. They run 2 runs, and then they let it sit over the winter because they can't afford to do the heat. There's $60 million you just paid, by the way, just to build the farm. $60 million. It's a $100 million project, and it only has a 9% internal rate of return. People, my model has a 38.7 internal rate of return. When I said to them, why aren't you doing this? And they said, all those high-tech farms all went bankrupt over the last 5 years, Tim, so we don't believe in high-tech. We're going back to old school. So investment's going the opposite direction right now. So how do we draw investment back over to agriculture? We talk about energy. And when you bring energy back over, right, it all starts to make sense. The 50-megawatt nuclear reactor, batteries. Modern nuclear reactors are batteries, people, right? You can put them within 50 feet of a sidewalk or McDonald's. They're placing them under 35,000 population student universities right now. They're based on a technology that doesn't need to be cooled. I like it. It's called pebble bed technology. They take the little tiny pieces of radioactive material and they wrap them in different protectors, right, so they don't overheat too much, and they put them into a substrate, a carbon substrate. Okay, who in the room has ripped apart a battery before? Anyone? Okay, yes, yeah, we did it, right? So that's what it looks like. It looks like a carbon husk inside. It lasts for about 8 years. You buy 2, offset by 2 years. So you put the first one in, 2 years later you put the second one in. In 6 years, what do? You take that one out, you put another one in. What do they do with it? Well, first and foremost, it doesn't have water. So there's no water, right, circulating through a nuclear reactor, potentially confusing it and making people concerned about water going on. Right? So it's not that. It's based on technology we had running in the desert without any cooling since 1962, from 1962 to 1994. EBR-2, a breeder reactor. They don't melt down. We proved it. By the way, 3 Mile Island. Everyone know about 3 Mile Island, right? We all think 3 Mile Island, that was that nuclear reactor that failed. No, it was not. That was the time we proved that nuclear reactors are safe and you can safely shut them down. How do I know? Because they're turning on EBR-2 right now. Why? Because it's safe, right? Who's turning it on? Google. That's who's turning it on. Why? AI, right? They need it. So we're going back to these legacy technology. I think that Holtec will probably be putting in 2 SMR 300s in Plymouth probably over the next several years. And those are newer, small modular reactors. They had a 600 in there before, one single. Now there's going to be 2 3s, but they're smaller, and they swap out every 10 years, right? So it's a recyclable thing. So the recycling goes back to the pond. I don't know if you know this, but you can take an electron and you can pop a 235 uranium, and you can make it a 238 by recycling. It's called a breeder reactor. And so right now in Plymouth, we've got nuclear waste, lots of it. Do you realize that the legacy nuclear reactors, what we call Industry 3.0 reactors, they only use 10% of the fuel in the rods, leaving 90% fuel waste in the rod? A new reactor uses 90% of the fuel in the rod, leaving only 10% behind. If I get my way, I'm going to get access to that nuclear waste, and it's going to save me $23 million a year with my plan, if we can get the Plymouth Food and Energy Hub in place. I'm hoping what I'm showing you is some synergies across these technologies, right? That when we break them all apart into this first principle construct, just pull them apart. What are they made up of? And then if we wanted to squish them all back together, what would it look like? And how do we get the efficiencies from all of them and put them into one pile? I love the idea that one of the other things I like to think about when people talk about nuclear is, did anyone see the protest at the hospital when they put that new radiological X-ray machine in? You didn't see that, did you? No. There were no public picketing signs, right, for that nuclear device that went into your hospital. We have them all over the place. That nuclear device we call an X-ray machine, right? Well, that's what a new MMR is. It is no different. You will call up. It will be built somewhere else. It will be certified safe. It will be delivered on a flatbed truck like a generator. This is the world we're moving into. It'll be managed services. They'll drop them off, and you don't have to have a nuclear engineer there. Island mode, right? Totally safe in island mode. So these technologies that are safer, they lend us to environments where we can make money off of energy if we're in a food business. You got this, right? So when I put these numbers through my AI team, all of a sudden something popped up. Carbon credits. I was like, what do you mean? AI? What do you mean carbon credits? It says, do you realize that greenhouse you're putting in protects pollinators, and there's carbon credits for it? Do you realize that there are large multinational companies that are not green, they want to be green, they'll buy your green for money. How much money? Well, you could make like $2 million. What is just $2 million a year? That is a huge P&L, $2 million a year. And so we started looking at food. Remember that highly volatile CPG packaging world is very volatile. You can't maintain your revenues. They go up, they go down, depending on the market. The economy's down now, we're all down 30%. But we're a manufacturer under multiple brands in CPG. That gives us a little bit more sustainability, right? A little bit more diversification. Passamaquoddy Indian tribe out of Maine, they've been picking by hand 1 million pounds of blueberries every year. They were the indentured servants of the freezing house for decades. Take my berries and give me my 8%. They discovered our company, who's helping agriculturalists develop their own CPG products, consumer packaged goods, shelf stable. And we brought them to 45% margin, and they're now shipping nationally right now. This is an Indian tribe suffering with 8% margin business to what they do, and they couldn't figure out a way to get any more margin. We said, we'll just freeze dry it for you. And now we freeze dry their brand, and we ship it all over the nation by the pallet every month, right? This is providing margin back to that farmer, right? It's providing margin to me and my company, right? And it's proving that we can be the supply chain for the nation. We can be the supply chain for the nation. After this slide, you're going to understand that we can be the supply chain for the nation. But let's talk about business models. I've sat through many a pitch in my career. I'm sure you all have. And if you're in venture capital over the last 4 years, everything that you heard about is AI. I talked to a few of them, And they said, what do you do with AI? I said, no, nothing like you hear about, right? Because they're all going agents, all this stuff. We use AI in the back office. I said, but let's take a look at multiple market segments and see if we can't, after this first principles deconstruction of all these different silos, let's look at a business opportunity. And can the business opportunity justify putting it back into a pile? It can. The CAGRs, compound annual growth rates, are pretty attractive. CPG and freeze dry is only at 8.6, but I'll have you know that my legacy Industry 3.0 competitor, Thrive Freeze Dry out of New York, just went bankrupt. They spent $50 million back in 2018 building a freeze dry company, and I can tell you today that I'm 46% more electrically efficient than their plant is. That's why they went out of business, right? Their energy costs are exorbitant, right? So vertical farming, I told you right now it's a good CAGR, but the CEA is growing. I just had someone invested there, another one in Kentucky. They're going in, big 25-acre things. But they have very low internal rates of return as their spec, because they're pure grow food. Grow food for this one buyer, right, who's going to buy all my 5 million pounds at once for this small amount of money. That's their business. No bend, no flex. We can improve that. Solar energy, as we know, is the incentives are going down. But at the same time, if you're trying to offset your costs for processing, and if you get a battery backup, you get some solar, right, you're going to be processing 24 hours a day, you can clip your load, you can save double digits in percentages. The carbon credit adds a whole new dynamic, right, especially if you build your own nuclear power plant, folks, right? Now, and you put in a bunch of controlled environment agriculture, now you can really put it all together. Co-manufacturing. Tariffs, anyone? 94% of businesses in America right now are experiencing supply chain concerns. 6 years ago, when I had to futurize what I was going to be doing now, I thought to myself, I just left corporate America. I don't know your politics, but I saw Donald Trump and the GOP coming in, and I thought, they're going to do something not so positive for small business. You can argue whether I'm right or wrong. I feel I'm quite right about that. And so we thought we should be doing things that might want to improve manufacturing capabilities in the US. A raw material cannot be consumed by a manufacturer. It can't be. But what if you can condition the raw material? Say a blueberry. Freeze dry it. Now it shows up in your cornflakes. Strawberries, cornflakes. Bananas in your morning breakfast shake, smoothie, or mixed drinks at a bar. We have some folks that make pina colada mixes with some of our stuff. Right? Just different ways to look at the technology to create components. Right now, our little company is the premier freeze dryer on keychain.com. Keychain.com is a darling of Silicon Valley, well-invested group. They also knew 6 years ago that supply chain was going to be a problem in America in the coming years. We have plenty of soybean right now if you need it, but anything else, you're going to be in a lot of trouble. So supply chain is a problem. American manufacturing doesn't exist. I'm the only freeze dryer only licensed freeze dryer ever in the history of Massachusetts. Can you believe this? Right now, the only standing freeze dryer in the region. Right? I've got contracts pending right now from large multinationals that we all know. Right? Bringing business from around the country back to New England to consume our agricultural resources to be shipped back out across the nation. Last year, this time, we shipped 1,000 cases of New England apples to Washington State. So if you're a New England farmer, what I just said, your hat would have blown right off, right? That has never happened before, right? We're proving that you can turn raw materials into consumable co-manufacturing components, and we can do it across multiple spectrums. Why is this important? Well, Lesser Evil was purchased last year for $750 million. Why? Well, they built a healthy snack platform that could make popcorn and pop snacks. Excellent. Wellness Croft has a healthy food platform that can make meals, fruit snacks, instant coffee, pesto, like 1,700 other different products. Anything in freeze dry can be made. We got a guy who's a basil farmer. He's like, I got a great business in basil. He goes, but it's shelf stable, it's not there. What do we do? I go, you got any extra basil? He goes, yeah, the stuff we call waste. I look at it. It's waste to him. Right, the leaf is not this big, right? You want to spend $5 on your little basil thing, it has to be perfect. But they grab them, they drop them down. He's got a 30-pound box of the most perfect-looking basil I've ever seen. He calls it his seconds. We turned that into shelf-stable pesto for him. And now he sells shelf-stable pesto, right? He doesn't have refrigeration concerns, right? He now has a product that anyone can take a teaspoon of it, and drop it on your pasta, and you've got pesto pasta, right? The idea that we created a platform in New England to manufacture multiple different product categories seems as valuable as a company that can make popcorn. So, adding all of this up makes a pretty big market. We've talked about the decomposition of the technology and the silos across them, and if we reassemble them, we might be able to come up with an idea to address this total addressable market. How much is that? 50 billion. That's a very large market. When I met with Derek Brindisi, who's the town manager of Plymouth, wonderfully progressive gentleman, and we're talking about the Plymouth Food and Energy Hub and how important it is to Plymouth and how he wants it in Plymouth. And he'd really like me to do a private power and light for Plymouth so we could save all the consumers' electricity and save the town because they can't do it themselves. They need a third party. We want to do that stuff. But when you look at the overall opportunity here, I said to him, you've got a bunch of projects going on in town, right? We've got the 1600 project going on. And that's to take, what are we going to do with the old nuclear power plant? It's a publicly funded project, got consultants, we're doing town meetings all over the place, everyone's gathering together. And I said, did they ever tell you how much opportunity we have? And he's like, oh my God, Tim, you're right. We've been studying what we can do, but we don't even know what it's worth. I said, and the problem with this is, how are you going to fund it? He said, well, I could get some funding, to go buy the land over there. I go, no, how are you going to fund us leading the nation, creating an economy here that we ship out? And he's like, you're right. No one's looking at what venture would look at. What is the total opportunity here in town? It's $50 billion. Are we familiar with how other countries are solving food issues? How about the Netherlands? I think it's like double-digit worldwide support. They feed the world. I think maybe it's 9%. They feed the world, right, with these greenhouses. Spain, southern Spain, feeds Europe. These two locations right now are some of the largest agricultural zones we have. They're all legacy, Industry 3.0. None of them have power, providing free heat. All of them are competing on a global scale. I don't want that for us. What I want for us is I want a version, if you will, of the Netherlands in this area. Why? Well, if I can overcome the costs with electricity, today I can go right on the internet and I can say, USDA, what is a pound of beans cost today on the global market? Everyone goes there, they know what the market price is right now. And we all have to compete with that market price. It's very hard for a New England farmer to compete with that price because of his capitalization, his energy costs, his labor. But what if we could get that energy cost out and turn it into a profit center all of a sudden, right? And what if I could do an adjacent business out the back because I've got food waste and I've got heat? Hydrogen economy. Right? Wait, money. So now there's really money to start to pay for it all? This is how it all starts to come together. We have here an opportunity to put it all together for the nation. We've got technology, we've got a business opportunity, and we don't have any competition. How is that? This is disturbing. This is a climate Titanic right now. I mean, look at the tagline here, right? It's not cooking your workers, right? I mean, this is the reality we work in. People don't seem to care. Right now, they're chasing the labor away, leaving less labor to deal with this problem. This is our competition, folks, right? 75 feet. That aquifer right here is down 75 feet. It took the forming of the Earth's millennia to fill that aquifer. It's not getting refilled, folks. They're draining it faster than we can do anything about it. 98% water less usage in our plan. They're killing workers. There's a 410 years, 400% increase in deaths. They're killing workers. Why are we killing our workers? To compete in a market that we can't compete in well at price? Things have to change. New England has an opportunity here. Look, the next nuclear power plant's going in 2030. It's in Michigan. We could be 2030 or 2031, right? These nuclear power plants, they take up 2.5 acres, right? As I said, they're as safe as an X-ray machine, right? They bring a level of profitability to these kinds of ideas that will make this problem go away for us. This problem, it's not going away, right? So if we get all of our stuff right now out of this valley, and this valley's having all these problems, and we're also, now you know what's happening with labor, and you know what's happening with agriculture. We're collapsing agriculture right now. I mean, everyone I know in agriculture is collapsing right now, okay? I've got friends who just put $50 million on a vertical farm in Maine. They can't capitalize it, right? It's just, there are farms being bought right now for So it's not just here, right? The last 10 years of everyone, we're going to go vertical farming and over-investing without enough technology, right, all went bankrupt. There was an article 2 years ago in the Wall Street Journal. The whole entire vertical farming market went up and has come back down. And so now they're nervous about investing. These headwinds, right, are challenging. And so having to find really differentiated solutions to overcome these headwinds, that's what we're working on. So, we talked about first principles, decomposition. This is the idea of looking at anything and pulling it apart to its base parts. There's some nice words I have here about the little components. So, here we are. First principle thinking. Breaking complex systems down to the fundamental truths and rebuilding from there. We're deconstructing food and technology, not as separate industries, but as that raw potential. When you decompose these ecosystems, we find hidden pearls. Agricultural waste becomes an energy substrate. Food processing heat becomes precise thermal engineering. Nuclear infrastructure becomes a heat process and optimization platform for us. We're not integrating existing systems. We're deconstructing them to the atomic components, calories, joules, carbon molecules, and reconstructing them with strategic intention. A strawberry isn't just a fruit. It's a nutritional potential, thermal energy, carbon sequestration, and technological substrate. Our nuclear microreactors waste heat becomes greenhouse climate control. Food processing waste becomes hydrogen feedstock. AI optimization becomes transferable intellectual property nationally. We're not building a company. We're creating a living, adaptive, economic ecosystem where every input is an opportunity, every waste stream is a resource, and every technological node creates multiple value streams. Venture capitalists don't like this often because they see different piles and they want to see a cogent strategy to scoop up the piles, right? They don't want you to be the end-all, be-all, I'm that fax machine that can print and copy and all that stuff. No, they want you to be, so this is dangerous talk for a guy like me when talking to venture capitalists. So I have to get it down to a cogent pitch. And so right now in our work, two gentlemen who I should have introduced probably as I started from my team is we have Tim Patterson in the back and we have Mark Ludley in the back, Chief of Staff and Chief of Operating from Wellness Croft. We're working on putting together our pitch night right now. We're raising capital alongside the grant and funding work that we're doing. There's plenty of grant and funding available. I have great relationships with my political sponsors. In fact, Michelle Badger just handed me one 4.5 weeks ago and we put it in last week. So she says, oh, you're a good company. We want the funding to go to you. Here's an energy saving bit. Can you save us some money? And I said, yeah, I can save you $600,000 over the next 5 years in energy. She says, it's a great idea. Put it in. So we are. But there's lots of these different pieces for the innovation revenue streams. You can see this power sales piece. This was a piece, these pieces came up through AI for us, right? We didn't think to go there. I'm an electrical engineer. I think I got it all nailed, and all of a sudden, hey, like, wow, that was totally random, but the totally random piece adds so much to the pile. So if you wanted to build one of those beautiful maps I showed before, the food factory, the future, kind of that Plymouth Food and Energy Hub, we've got it at about $500 million is what it would cost to build the whole thing out. And so we're looking at a short term. We're raising under a couple billion right now to get us to our what they call the magical 2 million EBIT. This is getting to $2 million in revenue, and that's when you're very attractive. From there, we're gonna try to raise about $35 million. That's going to give our first prototype of the farm, and the factory, and solar energy all integrated together, all in one spot. We're hoping to find other interested investors who see the idea as maybe more important and something that needs to move a lot faster. And based on our internal rate of return modeling, we're probably a better investment than buying a failed farm that they're investing in right now, or trying to figure out how to solve their conundrum right now, like in Maine on all that solar they got into, or the wrestling with the federal government over their wind project. And there's a lot of trouble right now with these venture capitalists right now. And so we're trying to create a cogent plan that shows them how they can start to invest right here. We have political support, we've got town support, now we're trying to move into that investor community. So it's a universal principle, right? But just local adoption. Think globally, act locally. This is a rural renaissance opportunity, I like to think, because it gives places that have a couple of spotty farms that used to have a whole bunch of farms, our whole economy was farms. It gives the ability for those people to aggregate together, maybe pool, and maybe put their own food factory of the future together. How about one on the Cape? How about one out in Western Mass? I'd like a whole bunch in Plymouth. What about the rest of New England? How about the rest of the country? Massachusetts as a national leader, as the blueprint for it all. This model isn't just for Mass, it's a blueprint adaptable to any region and agricultural base, and really any energy resource profile, because some folks do have nuclear already, right? Some folks are moving that way, so you can blend it together. Every congressional district has an agricultural resource or an energy need. It has workforce development challenges. Specific technologies might vary, solar in Arizona, wind in Kansas, but integration principles, they do remain constant, right? The idea is energy adds a value in profit and in carbon credits. Rural communities struggling with economic decline can create high-tech, high-wage jobs while supporting agricultural heritage. I'm on the council down here, the planning council. We're helping look at our agricultural plan. There's an RFP going out right now for you folks that know about the community planning that we do in Plymouth. But that's happening right now. Urban areas can address food security while creating energy independence. But the Massachusetts opportunity, right, is that we can be first. I like being first, right? Did the first video call from here to China. It was a telemedicine call. There was a girl in China, cardiac issue, small girl. They couldn't figure out the problem. Massachusetts had the premier physicians in health, right? I mean, Brigham and Women's, cardiac, this is it. This is cardiac for the world. I was able to set up the first international ISTN call. We had a panel of 12 physicians, and they helped save that girl's life. These are firsts, right? First video call. I was driving down the highway about 70 miles an hour in Tel Aviv one year, and the phone rang, and it was the first mobile video call over the Ericsson VIG system, right? Our boss, Ed Ellett, the guy that ran the video division for Polycom, he's at the table. He's like, where are you guys? It's dinner time. Where are you guys at? We're in the car, driving through Israel. It's the first, right? Look, I see these things before they get here. It makes me a boring person until they're here sometimes, or maybe irritating, but it's coming, right? This evolution is here now. Fundings are being aggregated right now. We have the opportunity to be the nation's first. And that's what this is all about, right? Us being the emanation site where we can start popping these things out. The franchise business opportunity creates about a $15 billion business. Now, why do we want, so we're starting out with the Food Factory of the Future prototype, right? We're trying to get funding to build really the Plymouth Food and Energy Hub, right? For me, it's going to cost me at least $100 million to get the first like real neat looking piece in. But when we go to franchise, the franchise in for the first buyer is only $5 million in, not $100 million in. Do you see the difference here? So if you could start creating this kind of opportunity for people that only need to get $5 million in to start, because it's all a franchise opportunity that spins off $60 million in revenue per site per year, people are going to start to adapt the Food Factory of the Future if they can put it in for $5 million and it solves their local food and energy grid problems. And I'll stop there. Questions, please.
And thanks for sharing the vision of the future. How critical is it for you to get access to the total nuclear power plant? Is that critical?
I thought it was more critical initially. It's not. In fact, right now, my last conversation was with Derek Brindisi. He said, Tim, I need your help. We can't get Haltech to the table on they're going to keep the land. We have right of first refusal, but they're going to keep the land. I said, well, that's a shame because we could use that land because it's got nuclear. And then I finally said, you know what? Who cares, right? Because the regulation that we're about to change in Massachusetts is going to allow for nuclear to go anywhere. The federal changes that Massachusetts is absolutely mapped to. I've written a recent paper called Demystifying Massachusetts Nuclear Renaissance. It covers all of the laws, all of the changes that are happening, everything that's happening between Massachusetts and federal. It's all pointing to a nuclear renaissance here in Massachusetts. I just updated that last week, actually, and I've had a few folks from MIT, nuclear folks, and I corrected some of their work because they'd selected the wrong architectures. And they were thankful for that work. But they looked at some legacy technology that wasn't quite what we're talking about here, these pieces. But it does not require, in fact, a couple of developers in Plymouth I'm working with right now. There's a 35-acre site, Hedges Pond, available to us right now that we could move into. He's got an 1,100-acre adjacent site. He's got a 50-acre site. So all over the region, we can isolate locations. We only need 2.5 acres for these nuclear power plants. That's the federal buffer, 2.5 acres.
So why Plymouth versus a different location?
So right now, everybody drives their trucks into the Chelsea marketplace. I want those trucks going to Plymouth. We got 95, we got Route 3, we got 195, right? We're in a location right now, Cape's right there, that we could be the food hub of this region if we're growing it. I just envision 1,100 acres, right? We got 1,600 acres. There's a lot of land in Plymouth, right? So there's an ability to put in a 200-acre site. Well, actually, so we're working with technology that does double the density. So not a 25-acre, an 11-acre. So 77 acres. If you put in 77 acres, you could grow the top 14 fruits and vegetables we all purchase every week. And because we had an electrical substrate, and we've got this back end with hydrogen, right? We have a great business model. We're competing at that USDA market price, the same price, maybe a discounted price, right? So why would people go into Boston when they could come to Plymouth and save money? Is my view. Yes.
This was fascinating. I had to run to catch up with your stories. And I probably need to listen to it 2 or 3 more times, but I'm a 26-year Air Force veteran physician, and I wouldn't be here if my husband and I hadn't eaten a whole food plant-based diet for the last 10 years. We had a rough year, and if we hadn't been as healthy as we were going into that year, we wouldn't be here. So the things that jump out at me, first of all, the vertical farming is absolutely the way to go, and the Netherlands, and feeds way more than its share. And as you pointed out, they save something like 98% or a huge amount of the water, almost no pesticides or herbicides.
Foodborne pathogens, very low foodborne pathogen issues. Yep.
And it's clean. So there's lots of things to be said for vertical farming. And also the freeze drying is fantastic because you maintain the nutritional value.
100%, by the way. It's the only method that 100% of nutrition is saved through freeze drying. Everything else is lost.
And my very meager understanding of freeze drying is exactly what you said, is that the big drawback is the energy requirement. But once you have it, it's, I buy some stuff that's 20 years shelf stable, freeze dried stuff. And it's definitely a way to go once the food is in that form. And it's lightweight, so the shipping is less. I mean, on and on and on.
No refrigeration, no cold chain management, no food safety issues. Right. Again, when I started the company, I had never done a food company before, but I'd done international standards in telecommunications, and so I knew that. So I looked at all their standards, and I built a company that has only one food safety issue. One. And that is, do we dry it enough?
And this would be an absolutely tremendous product for the military. MREs are among the worst nutrition out there, and this could revolutionize that. We do a freeze-dried ice cream, and one of my friends was like, this is a morale booster, right? This little bag of freeze-dried ice cream comes from, from FOMU. It's fantastic stuff. It's plant-based. Everything we do is plant-based. My family and I, we're plant-based. My 16-year-old son has been plant-based since he was 1 year old. We did it for health, and we find it healthy. It's also 300%, it's growing 300% faster in grocery. So it's good to be in plant-based and healthy foods. But I thank you for your point, because that's really what it's all about. We started this whole concept with food, right? How do we feed ourselves, selfishly as vegans, and there's not a good food supply here, and we looked at freeze-dry, and everything you get from freeze-dry is, just so you know, freeze-dry that doesn't come from here is based on food waste. So Europe, it's food waste. Asia, it's food waste. There's no nutrition in it before they dry it. It's just crunchy and colorful. Our stuff actually has the nutrition in it, right? It's a totally different way of looking at it. The water saving is huge, because you're right. The whole, southwest quarter of our nation is, I don't know what they're going to do without water. They're headed in that direction very, very rapidly.
And you've got communities trying to poke at that same water supply and move it out to the desert right now because they've got this giant community. There's a lot of fight over that water. But thank you. These are good points. Yes, sir.
Very creative. A lot of high points. I just want to come back to a touching point now.
Yep.
Aye. So remind me, what small nuclear reactor, what's your cooling technology? Liquid sodium?
Yeah. We like those. But there's heat pipe. There's heat pipe also. So Westinghouse is probably going to get the first one that goes in. They do. They've got it. The Indian Head one that's going to Michigan, it's heat pipe based. No, there is no cooling on it. And the point is the efficiency. No, that's a heat pipe. There's no sodium in even that one. The other ones that's going in right now, there are sodium reactors that are going in right now that just keep the salt, right? And they don't have external cooling. I like those. They're called very high temperature reactors. Nuclear is dictated by Japan, as you may well know. Yeah. Yep. Right. It's engineered to, this is a great question, right? Everyone gets this one a little different. They're afraid of the meltdown, right? So very high temperature nuclear reactors are built not to have cooling. They're built to have latent heat. So my power plants in the Navy were 1,200 pound steam plants, right? 600 degrees Fahrenheit, right? That's about as good as they can go. Nuclear reactors, original 3.0 ones, they couldn't get too hot because they'd melt the steel, so they needed to cool them because they weren't smart enough to engineer the physics around self-containment. Industry 4.0 said, wait, the one thing we could really use is more heat and not get rid of it. It's a latent heat source. So Nagasaki, the tsunami that knocked over Japan, they shut every reactor in Japan down, except for one. Which one? The very high temp reactor, the one without cooling. Why? The same reason we ran one for 40 years in the Utah desert, without cooling, right? Because we want that latent heat, and we want something that can be island mode, where we don't need a reactor monitor in it. They're latently safe, is the point.
It all makes sense, but what did you do before? What the nuclear waste?
Oh, okay. So it depends. Yeah. So pebble bed. Yeah. So pebble bed. It's going to show up. So a shipping container. They're like 25 feet. That's what's going to show up in. That's going to be a 50 megawatt reactor from Oklo. It's going to run for 8 years. When it starts to wear down, right, they're going to bring another one in, and they're going to take that one away. And remember my question about you ever open a battery before? They're going to open the battery. And inside is a pebble bed technology core. That is designed to not need heat to cool. They wrap ceramic around every single piece. And when it stops performing, they come and take it away, they break it back down, and then they reflash it in a breeder reactor and turn it back into 238 or 239, which is relative fuel, and they make it back into fuel again. There's a fuel recycling process built into the FISOL mechanism. There is no waste. It's a closed circuit by which you get it, they get it back, they reflash it, and they send it back out again. So his question was about local versus centralized. So everyone remember the IBM days? Okay, all right. You got a couple. So I'm like the first PC guy, right? I saw my first PC in like 1985 or something like that. 84? No, 87. First PC. Your point is right now we disaggregated farming and we turned it into giant factory farms, and then we figured a way how to economically take the whole market away in one fell swoop. That's soybean right now. That is a centralized model, and I'm advocating for a decentralized, a PC-like structure for economic development. You do not get to look. Here's the problem: you're either thinking about your people, right, which is I call economic democracy, right, or you're thinking about corporate feudalism, whereby which no one here is the owner of the company, someone over there is the owner of the company, and no one is making decisions about the people here for this region. They're all being made remotely. Right, and so my model is economic democracy, by which we think of our people, we think of their longevity. I like things called pensions, right? My company will have pensions for the people, right? That's something that we used to have, right? But it brings back the value locally. And once you start having local, you get local investment, you get local political support, right? You get local jobs, right? We have to rebuild our economic system. That value is going away, right? The way we get it today, we don't get anything locally here. Everything grown in New England gets rushed right up to the farm stand because they can get retail on it. They can't sell for wholesale margin. We're a boutique. We're farming here in New England. I hate to say it. There are some great farming families that are still doing it right. I've got 42 orchard families that have been around for hundreds of years. They're still doing it right, but it's still a challenge for them. It's more of a kind of a experience marketing, like come to our for the blueberry picking and stuff. It's all about experiential marketing for them. That's not their business plan. They're an agriculturalist and they can't make money doing it. So I believe by decentralizing, right, the opportunity and bringing these food factories of the future that bring hydrogen, nuclear, food, automation, architecture, robotics, all these jobs, all these local sites, we can overcome that challenge. Yeah. Oh, I'm sorry. One more. Yep. Go ahead.
Do you want to bring produce to you to a facility, or are you looking to set up on top of farms?
So right now, we are working on building an individual quick frozen tunnel in Massachusetts. There is no individual quick freezing tunnel in Massachusetts. Right now, the Boston school system this year, their only consumption of food from Massachusetts is 18% of their menu. Every meal, they 4,000 pounds of vegetables for every one meal in Boston school system, only 18% from local supply. They're working with us right now on a Mass Innovate grant, where they're going to be the customer to tell us exactly what they want to buy locally. So Mass Maritime, Boston school systems, and Plymouth school systems are working with us right now to be the customer base. And in this scenario, we are aggregating food that was never aggregated before into a local production facility where we can freeze it, store it, and then dole it back out to the school systems over the year. They can't store it, right? There's no one that aggregates it. We have the ability now to, by the way, you get the order in February. You don't have to start delivering until the fall. So if we get this done right, by June of this year, we'll hopefully have a new tunnel in this region. So right now it's about food processing. Try to get what we get and try to get it back into the consumption pool. But as energy comes along, it's about growing it now.
How do you define tunnel?
So an individual quick freeze tunnel is something that's about same as a cargo box. It has air, it goes down to negative 45 Fahrenheit. It's got oscillations inside that juggle stuff, so it keeps it individual, and it flash freezes it. Flash freezing happens within very short seconds, and if you flash freeze something and you thaw it out again, you don't know it's frozen. Because it doesn't have big ice crystals that break the flesh. It has micro ice crystals, so if you can flash freeze it, you also save all the nutrition for 2 years. And flash freezing is the first step of freeze drying. Freeze, then dry it. It's 24 feet long, about 8 feet high. And it uses about 800 amps of power.
Do your nuclear power plants depend on the Price-Anderson Act for insurance?
I have no idea. Right now, a lot of regulatory in flux, but all moving to make it easier. So in Massachusetts, they're trying to get every encumbrance away from the proliferation of nuclear. Our Senator Fernandez, he wants energy everywhere. He understands the value of it. This question about putting them other places, I'm not sure specifically.
Then the other question is, you pivoted the last presentation you talked about solar. So can you discuss the difference between doing this whole process with renewable energy versus nuclear?
Yeah, so renewable energy, so cost physics is a really important question. Your question is based on cost physics. What's cost physics? How much energy do you get out of that piece of thing, right? And the cost physics of solar is very poor. The cost physics of wind is very poor. The cost physics of nuclear is absolutely astronomically off the chart, right? It's just like, oh my God, look what we found. And so there are scenarios where I still think solar is viable. Sometimes they'll put in a 25-acre plant and they'll put in a 25-acre solar array next to it. You have to take up the same amount of acreage, right, as you do the plant. That's not good land use. And so over time, and you also can't get as much carbon credits for it, and you also can't get as much offset for energy costs. So it doesn't provide the cost physics that make for the business plans to work.
But is that dependent on your time frame? Because you're placing that plant every 8 years, whereas the solar shouldn't be there for a lot longer.
Well, I mean, I think, so someone said to me last week, well, why are you even talking about, fission, right? Fusions, right? so I'm like, look, here's what I know. I know what we can do. And I know where all the regulatory is going. And let's just do that, right? Let's get one in, a small one, a 1 megawatt, who knows? So 50, let's get it in. Let's go through all the processes. Let's see if we can vet it and see if we can't make it a national, springboard. Oh, there you go. There you go. My pleasure. Thank you all. Thank you.